Guys, welcome to new video. Today we are going to configure a vrrp which is used for gateway redundancy. So this IP we are going to use as a gateway for clients which are connected to access layer switch. There can be multiple clients which are connected to this gateway to talk to outside of the network, and we have two routers or switches which will act as a vrrp gateway. This is the primary and this is the secondary. So what is we are going to do is we are going to configure this switch 3 as vrrp master and switch 4 as vrrp backup. These two switches will have this virtual IP. uh, so the public IP will be different on these interfaces, and the virtual IP which will be used by the clients is will be same on the vrrp configuration on these two switches. So in the traditional network, what happens is that if this interface is 192.168.1.254, right? Suppose let me redefine. Okay, so suppose we have only one router as a gateway. Okay, and this is a switch and this is a client, right? So in the traditional network, what we have is that we have IP like 192.168.1.255. This will be our gateway for this client to reach outside of the network or outside of the local subnet. Suppose this router's IP will be 168.1.1 client IP, right? And the gateway to reach outside of the network will be this IP address, which will gateway for the client will be 192.168.1.254. So if we want to ping Google 8.8.8.8, right, and this is the outside, this will be the public IP address, which will be in the range of something like this, uh, depending what ISP gives you. Okay, so what happens is that if in traditional network, if these clients want to reach the Google, so what it will do, it will check that the IP address that the destination has is not in my subnet. This subnet is belongs to 192.168.1.024. This is not in my subnet. So what it will do, it will send the packet to gateway, which will be this IP address, which will be 192.168.1.254. Client says that I don't know where is this destination, so I will send this traffic to my gateway, which is this interface, which is a physical IP address of that client facing interface. Okay, this will be the gateway for the client. So this interface and this router will send traffic via its public IP address to the Google. Now the problem is that this has no redundancy. If anything happens here, so network will be down, right? So this network will be down and the client cannot reach the outside of the network. So that's why if we take multiple connections from multiple ISPs, This is our router, customer router. This is client. So what happens is that it can be a layer 3 switch also, depending on the network topology. Or also this can be a same router of the ISP, okay, or the same physical interface which have public IP address in the range of 10 something x, and this IP address in the range of 11 uh, 8 at public IP. So what is the situation here? If this is our primary link and this is our backup link from, this is ISP1, this is ISP2. So the primary gateway or primary router will send traffic. Client wants to reach the outside of the network. The traffic go like this, okay. So if something happens to this network or this side of the IP address or network side, something physical damage happens or a configuration issue, or this link goes down, the backup link will automatically become the traffic forwarder for the internet traffic of the internal clients to the outside till the primary link again comes up. If the primary link comes up again, then this becomes live or up, and the traffic again goes via this primary link. So for this to happen, like to have a redundancy in the networks, like before we had only one path, okay, so we did not have the redundancy. Now we have the redundancy because we have taken two connections, because our site is high priority site, so we have taken two connection from ISP1 and ISP2, and we have taken 50 Mbps link from ISP1 and we have taken 10 Mbps link from ISP2, because the charges will be higher if we use 50 Mbps on both sides, right? So mainly our traffic goes to this, but if this link goes down or anything happens that side, the backup link works for some time till the primary link doesn't come up. If the primary link comes up again, then the traffic goes again via primary link. And the protocol that we use for this situation, where we have a backup link to send traffic if the main connection goes down, we have three protocols, which is HSRP, which is made by Cisco. Second we have vrrp, which is open standard, and third is GLVP, which is used all the uh, virtual gateways and virtual forwarders will all the routers will send the traffic parallelly. This is also made by Cisco. So we are going to use the vrrp, which is open standard and works same like HSRP. This GLVP is advanced. Basically what it does, if this is our primary ring and this will become our actual virtual gateway, and all the backup links which are we are using will become the actual active virtual forwarder. Active virtual forwarder. So what happens is that instead of using only one link to send traffic, what the JLVP does is that it uses all link to send traffic. Some traffic go via this link, some traffic go via this link, some traffic will go via this link. So JLVP what is does is utilizes all the links, and we are not going to do the configuration for this. We are going to use vrrp because we have only two links in our topology. So what we will do is we will create one side vrrp. This switch 3 will become our primary gateway, and this will become our backup gateway for the our client side. Okay, so we will configure a vrrp now. So this router is access switch, basically our client is connected to this switch. This is our normal access layer switch, and you can see that if I show you here, I will take the screenshot again and I will explain you. In our topology, what we have done is our client side is not, hold on a second, our client side is this, you can see, right? So as the internal side we have used the 192.168.1.0/24 network. We have given this interface, and this is our subnet. This switch E00 and E00 of switch 4 and switch 3 comes under our client subnet. These interfaces, basically this whole network is under same subnets. So we will see what we have given on the E00 interface IP address. We will go on switch 3. We will see what is the IP address on this switch 3. You can see this is 1.1, 192.168.1.1, and this must be 1.2, 192.168.1.2. So these are physical IP address gateway. If we had only one gateway, so we would have used the 1.1 IP address for client to reach outside of the network. But because we have redundancy here, we are going to use a IP address 168.1.251. We can choose any IP address. This will become our virtual IP address for vrrp protocol. So the client, we configure client and the gateway as this address, virtual IP, because this virtual IP address will be on both interfaces. So the client doesn't know which is the actual gateway, and the layer 3 configuration will be separate from layer 2 configuration. Client will not know which is the client will understand that there is only one IP address as the gateway, but actually we have the physical configuration we have on the switch 3 and switch 4. So but the client understands that I have only one IP address, so anything down to layer 1 and layer 2, anything happens, vrrp can handle the transfer of traffic from primary or a master to backup. So the actual IP gateway will give to the client will be this. So I will show you the configuration. You can see that this is 1.1 and switch 4. The interface E00 will be shown on interface E00. It is 1.2, right? 1.2. And now we will configure the vrrp protocol. This will be our master vrrp. This will be our backup vrrp. You can say gateway because it is about gateway, right? So gateway, the protocol used for switching the gateway to primary or backup router or master router. And this is what it is used for. So we are going to go into interface of switch 00, interface of switch 00, which is E00, and now we will do configuration on E00 vrrp configuration. What we will do is we will vrrp1, this is group number, and then IP, the IP that we will use for the virtual gateway 255. Okay, we have given the IP. You can see this will become a master. Okay, you can see this is become master. So we will go on the switch 3, we will do same configuration on the switch 3 00 IP vrrp, vrrp1 IP address, IP address 192.168.1.254. You can see that this has become to show vrrp. You can say this router has become, the switch 3 router has become backup router. You can see here it has become backup router because of the condition that the physical IP address between the vrrp routers or devices which are in the same group. The one is a group number of vrrp. In that group we have added two devices, which is switch 4 and switch 3. So if we see to show vrrp, the IP address of the physical interface here, which is 1.2. This IP address in the vrrp group 1 is higher than the switch 3, which is in vrrp group 1. This IP address, this is master. Okay, so you can see here we show run interface E00 of the switch 3. You can see this address is lesser than the interface IP address of the switch 4. You can see. So in the vrrp group 1, how many routers or switches devices are there, and in that devices whoever has the highest IP address will become the master router. So you can see the switch 4 has become the vrrp master. Okay, and the condition to become the master is like condition 1, first configure first configured device. So whichever device in that vrrp group, in our case vrrp group 1, whichever device we will configure first will become the master. This is the first condition. The second condition is that whichever device priority is higher will become the master router in that group. And third is highest physical interface IP address. So here the third condition has applied. This is the IP address which is higher than this IP address, so that's why this become master. But in our case we want to make switch 3 as the master gateway, right, or vrrp master. So what we will do is that this is the current condition. What we will do, we will increase the priority on the switch 3 which will become then master. So we will go on the switch 3 and then vrrp group 1 priority to 200 we will give. You can see priority is currently 100, right? Master router priority also 100. We will make this priority 200. Now you can see something will happen here. You can see this router or switch become the master router. If we see to show vrrp, you can see this router has become the master router now. What will happen is that the traffic sent to the gateway by the client will go through this switch or router now, whatever we are using, and this has become the backup router. Whoever in this vrrp1 group will receive these notifications, and because the priority has changed, our priority we have increased vrrp group 1's priority on switch 3, that's why it became the master router. So it is master. Now this configuration is done. This is basic configuration. E00 interface, that's why is 0 we have done. We have put the virtual IP of our gateway. Okay, this is public IP and this is virtual IP, which is same on the switch 4 and switch 3. To show run interface E00 interface, you can see this is virtual IP. We have just we did not configure any extra configuration here. We have just added the virtual IP, and by default we have added it in our group 1, so this interface is part of vrrp group 1 now. So now we can also configure the security, that's because we don't want any other extra public or IP address to add it in the group without our knowledge. So what we can do is vrrp1, I think password or something like authentication. Yeah, authentication text can be, we are giving password basically. This is a password we have given. You can see what is the bad authentication from 1.2. So you can see because we have configured password now for vrrp group 1, whoever wants to join the vrrp group 1 needs to have the password which is root. So So now what's the log saying here? Vrrp bad auth from you can say this router which has IP address 1.2 in group 1 unable to join the group vrrp1 because the we have not added the password which is this. So without password can anyone who does not have the password cannot join the group. The password needs to match. Okay, so we will go and we will add the password vrrp1 authentication text group. So now we can see that, yeah, you can see this group also joined the vrrp group 1 because our password has matched between the groups or the devices who are in the same group. So now this switch 4 also the part of the vrrp group 1. This is also done. We have done. Now what we have done till now, we have created virtual IP address for our gateway. We have increased priority to create switch 3 as a master, and we have given the authentication to only specific devices can join the vrrp group 1. So now we can see, if I go on the client, if I go on the client and open, I have to give the IP address which are in same subnet 192.168, maybe 1.1 and 1.2 already occupied, right? So what I will do is 1.10 and 255 sorry, the gateway 192.168 1.255. This is our virtual gateway, right? This is our virtual gateway. If you ping our virtual gateway 192.168 1.255, you can see it is pinging, right? So now the magic here is, I will show you some things very interesting, how the actual transfer works between the master and backup. So you can see now currently our gateway, what this, both the switches have the virtual vrrp gateway which is 1.255 254 vrrp gateway 254 1.254. We have given IP address 1.10 for our client, right? Our gateway is 1.254. So this is a master currently, this is a master, and this is a backup, right? You can see if I go here, if I go here, do show vrrp, you can see that this is the master. Now this special thing is that the ping has ping is our gateway is reachable from the client, right? So if I want to see if the, we can see outside, we can go outside of our local network directly to the Google. You can see we are reaching the Google IP address, and now the actual thing is that we will trace from where we are going to Google. We will trace 8.8. You can see that we have added here, I will control C, already completed. We have added here gateway is 1.168.254, but the actual traffic is to reach to 8.8.8.8 is via 168 1.1 and then 13 and 8.2. So this is our E00 of switch 3, right? This is our E00 of switch 3, which is public IP address of our switch 3 on interface E00. Basically, here our traffic is going, we are sending traffic to gateway 255, but the traffic is going through here from next hop, which is what you can see is on the VPC. This is 1.1, right? This is 1.1. This physical interface is 1.1. 13.3, which will be this interface 13.3, and then this is my actual home router, which is 81.2, and then from my home router NAT 8.8.8.8. I'm going to clarify that this is our EVNG lab. Everything is virtualized on this side, but this address is my actual home router address. So because I am connected to my laptop and my laptop is connected to my home router, that's why we are going to reach the 8.8.8 from our client. So the next hop is my home router, and after that the hops are disabled, or they have for security reason, I don't know. I think you can see that the traffic is first going through the 1.1, right? So interface E00, this is our master router. What will happen if this goes down? What will happen if master, which is switch 3, and our vrrp backup, which is switch 4, if this goes down, the traffic should go via this backup link or backup router. Our gateway will be same, 254, our gateway for client. The actual traffic goes through the public IP addresses which are under the virtual gateway 1.2. So what happens is that the client goes to gateway 1.255 254. The 254 is located currently on public interface 1.1. 254 is here, 254 1.250. So currently the 254 IP address is located on interface 1.1 because it is the master. So the client will send traffic to gateway. The virtual gateway will send traffic to 1.1, the 1.1 to the forward destination. Now this is master. This has the power of gateway now, okay, and this is backup. Currently the public IP is 1.2, but the 1.254 gateway address is not used because the power of using that gateway is at master side. But if this master goes down, the power of 1.255 gateway will go to the backup router, and this will become a master. It means that now the virtual IP, which is our client's gateway, is at backup router. So the traffic now go through this router. Client doesn't understand which is the gateway. It does know that this is my gateway, I will send traffic to this. Okay, so whoever is the master holds the power to send the traffic out via virtual gateway. So if the master comes up again, so this power of sending the traffic via gateway will again go to the master. So the traffic will again go to master. So what will we do to see if actually happens? What we will do is, this is interface E00, right? So we will shut down this interface. The underlay public IP we saw on the VPC was the 1.1, right? This is our E00's address. Now if I shut down the E00, you can see something happen, like state has gone down. Okay, and you can see this has become the master now. On up, you can see this become the master now. So this has become the master now, right? Master router is for group 1 of vrrp is master router is 1.2, which is our switch force interface. This is the master now, right now. So this IP public IP address holds the 254 gateway of the client. Now this router or switch has the power of gateway right now for the client. So if we trace again Google from the client, what will happen? You can see that the current traffic is going via this router. Our is switch ports E00 interface. Oh sorry, so on interface E00 you can see 1.2. So our current traffic is going via switch 4. So this link is down, right? So that's why our backup router is, or backup link is working as a primary link currently, or like a 10 Mbps backup link. So 10 Mbps, whatever Mbps, it doesn't matter. The primary work of vrrp is just switching the gateways between multiple routers for redundancy. Client doesn't know that my gateway is configured on multiple devices. The communication happens to switch the gateways depending on the primary is down or not, who are in the same vrrp group. So whoever in the same vrrp group continuously talks using the hello packets for vrrp, which is 1, and hold down timer, which is 3 seconds. So if this switch sends hello packet to this, but this master doesn't reply under 3 seconds to the backup router, the backup router understands that my master has down, now I have to become the master router. Meanwhile, if it's the master router, still it will ping to the master, the original master, to see if it has came up or not. If it has came up, so it will again become backup, and this will again become master. So if I enable that interface again, so what will happen? You can see that, okay, you can see this is changed. You can see that it has become master again. So if we ping from the VPC to Google, you can see that it is using again 1.2, 1.1.